Hello friends, today we are going to see how we can design a impedance matching network with the help of a single stub. So we will design this on the Smith chart. So for this we will take one sum. It states that antenna with a load impedance ZL equals to 100 plus J100 ohm is to be attached to a 50 ohm transmission line with a shunt short stub. So here we need to determine the required stub admittance. Then we need to determine the distance between the stub and the antenna, and we need to find out stub length. So in here we need to find out YL, we need to find out D, and we need to find out the length of the stub, that is L. So how we can do this with the help of a Smith chart, that we will see. So for this we will first draw a prototype. Prototype says like that we need to design a single stub which is a shunt short circuited stub. So we will draw here shunt or short circuited stub at a distance D, and the length of stub is L, that we need to find out. So for this, the step number 1 is we need to write down the given things. Here the given things is Z0, that is a characteristic impedance, it is 50 ohm, and ZL, that is the load impedance, is 100 plus J80 ohm. So this 100 plus J80 ohm, we can't directly plot it on a Smith chart. So we need to normalize it. So for normalizing this, what we need to do? We need to divide this ZL with a Z0. So we have to divide each and every element of this ZL with a Z0. That means we need to divide 100 by 50. So that is equal to 2 plus J100 divided by 50, that is equal to J2. So your normalized load impedance value ZL will be 2 plus J2. So we need to plot it on a Smith chart. So we will take a Smith chart and we can plot this 2 plus J2. So how to plot this 2 plus J2? Here we need to find out where is number 2 written on the horizontal circle. It's here, or a horizontal line, it's here. So we need to trace this circle which is passing from a number 2 vertically. This horizontal circle we need to trace. Okay. Then our Jx value is plus 2. So here this is a plus 2. So we need to trace this vertical circle down. So whatever the intersecting point of these two circles, that will be your ZL, that is 2 plus J2, that will be your ZL. So like this we need to mark the ZL point on the Smith chart. Then the first step number 1 is we need to find out the admittance YL. So admittance YL. So what we will do? We will take this ZL. Then from the center of a graph, this is the center of a graph where R is equal to 1 is written. So this is the center of a graph. From this center of a graph, we will draw a straight line passing from center of a graph and ZL. And what we will do? We will just extend this line back. We will extend this line back. Okay. Then after that we will take a compass and take a distance in a compass, like from the center of this chart to ZL point, to this point. We will take this much distance in a compass, and by taking this distance as a radius, we will draw the circle by putting the compass on the center of a graph. So we will put the compass here and draw this circle, which is called as a VSWR. So we will draw this circle passing from ZL by taking radius equal to center and center to radius, center to ZL. We will draw this circle passing from ZL. This circle is called as a VSWR circle. This circle is called as a VSWR circle. Now, this circle, VSWR circle, will intersect the line which is we have drawn earlier with one point. So this is the point. So wherever it is intersecting, that point is called as YL. So YL is opposite to ZL. So this is 180 degree exactly from ZL. So the intersection of the line which is passing from ZL and center as well as the VSWR circle, this intersecting point is called as YL. Now what we need to do, that is we need to design a shunt stub. So whatever the design we have to make, we have to design with respect to the admittance YL. So as we want to find out other parameters like the distance and length with respect to admittance, we need to find out the wavelength at admittance. So for this what we will do, we can extend a line which is passing from a YL out of the graph. This line will intersect the wavelength circle. What is the wavelength circle? How to measure a wavelength? That I have explained in my previous video. So you can see that video how to find out the wavelength for any point. Then this line will intersect the wavelength circle. At that point we need to measure the wavelength. So this wavelength for the point YL that we are getting, that is 0.459 lambda. So this is the wavelength at YL. Okay, so we have found out the answer for first question. We have found out the YL as well as we have found out the wavelength at the YL. Now the next is we need to find out the distance of the stub. We need to find out the distance of a stub D. So to find out this D, we need to draw the circle that is called as R is equal to 1 circle. So what we will do, we will just go over all R is equal to 1 circle is already there in the Smith chart. What we will do, unit resistance circle. So we will just trace this unit resistance circle again. So that is the red colored circle. We have to go over this R is the circle which is passing from a number 1 horizontal circle, that is called as R is equal to 1 circle. So we will trace that circle again. So this is the red color circle. Now we can see that is this VSWR circle and this R is equal to 1 circle is intersecting at this point. Okay, so we need to find out the first intersection point of this R is equal to 1 circle and VSWR circle. So this is the point where they are intersecting. Now we need to read out this point. So what is this point? This point is like 1 plus j 1.57 point. And we simultaneously what we have to do? We have to find out the wavelength for that point also. So how we will going to find out the wavelength? That is, we have to draw the line passing from center and that intersecting point and out of the graph. So we will draw this line center, that point and out of the graph. This line will intersect wavelength circle at 0.178 lambda. So that intersection point of this line and wavelength circle will be the wavelength at this point, 0.178 lambda. Now we need to read out the position of this point. So how we can read out? That is, this point is lying on R is equal to 1 circle. Horizontal circle which is passing from this line is the 1 circle. So you can write 1 plus, as it is in the upper half of the Smith chart. So we have to write the sign plus j. Now we need to find this point. So for finding out the jx value for this point, what we need to do? We need to draw the line passing from this point. So there is no line which is vertical line passing from this point in the graph. So what we will do? We will draw the line passing from this point, or we will draw the vertical circle passing from this point parallel to the 1.6 circle, because 1.6 circle is near to this point. So jx 1.6 जो circle है, for that circle we need to draw the line parallel to this jx is equal to 1.6 circle. So we are getting it as j 1.57. So we can write the value of this point or the position of this point as intersecting point as 1 plus j 1.57, and the wavelength for this point is 0.178 lambda. Now we need to find out the d. So what is the d? D is the distance between this intersecting point and YL. So YL wavelength we know 0.459 lambda is the wavelength at YL. Okay, now we need to find out this distance from YL to this intersecting point. So if you want to find out this distance, you can see if, and you have to always move in a clockwise direction. So this YL is at this point, then if we move in the clockwise direction, we are reaching to the center line. At the center line, one circle is completed and the 0.5 is the value of a wavelength at the center line. Then above the center line, again new counting is started, like on the above center line the wavelength value is 0.0. Okay, 0.0 lambda. Below center line it is 0.5 lambda. That means one circle is completed. So what we need to do? We need to find out this distance between YL and the center line first. So we can do like this: 0.5 minus the wavelength at YL is 0.459 and the difference is 0.041 lambda. So the distance between YL and the center line is 0.041 lambda. Now what we need to do? We need to find out the distance from this center line to this point. So if you go on a wavelength circle, it is increasing from 0.0, then this is 0.01. In this way it is increasing, and we can see it is at this point the wavelength is 0.178 lambda. So now to find out the total distance from YL to this point, what we will do? We will add this 0.041 plus 0.178 lambda, and that is equal to what? 0.219 lambda. That is the distance D. So this is the first solution that we can obtain. This is the first solution that we can obtain with the help of the Smith chart. Now, if we observe the intersecting points of this R is equal to 1 circle, R is equal to 1 circle and VSWR circle, the second option is also available. Second option is also available. Then if you keep on moving in a clockwise direction, you can see here this R is equal to 1 circle and VSWR circles are intersecting again at this point. Okay, so we will just see what will be the possible distance from YL. This is called as the second solution, second possible solution. We can just check out what is the possible distance from YL to this point. So for this, what we will do? We will draw the line passing from center, this point, and out of the graph, and measure the wavelength at this point. So we can draw the line passing from center, this intersecting point, and out of the graph. The wavelength at this point is 0.322 lambda. So now the distance from YL to this point, that can be done by, that is we need to add 0.041 plus 0.322 lambda, same as that of the first point. So we are getting the answer, that is 0.041 lambda plus 0.322 lambda, that is equal to 0.363 lambda. So if you compare these two distances, you can see this second distance is larger than the first, and we have to always choose the solution which is very close to the load. So stub which is close to the load. So if you, that is having at a shortest distance from the load. So shortest distance is 0.219 lambda, that is solution number 1. So we will go with this solution, first solution, like we need to go with the distance, or we will go with this point, that is upper one. Okay, so we will go with this point. Okay, so now what we will do? We need to find out, now this is your distance D, that is 0.219 lambda. So this is the distance of a stub, 0.219 lambda. This is the optimum solution. Then we need to find out the length related to this d, required length of a stub related to this d. Why the length of the stub is required? That is, we need to make, or we need to nullify this J 1.57. So if you want to nullify this J 1.57, that is the impedance value at an intersecting point. If you want to nullify this plus J 1.57, we need to find out the length at where we need to add the length equal to minus J 1.57. So first we need to find out where is the point minus J 1.57 on your chart. So if you observe the chart, there is no R value. As there is no R value, we need to plot it on the periphery of your Smith chart. This is your minus J 1.57 point. This is the point. Minus J 1.57 point. Okay. So this point we need to locate it on a chart. So we will do the same. So we will locate this point on the chart, that is minus J 1.57. Then we need to find out the wavelength at this point. So for this what we will do, we will draw the line passing from center of a graph and this point. So this is the line. This line will intersect the wavelength circle at 0.340 lambda. So the wavelength at this point will be 0.340 lambda. Okay. So this wavelength we need to note down. Now what we have to do, we need to find out the length of the stub. So the length of the stub can be decided based upon either the stub is short circuited one or open circuited one. So according to our sum, the stub is short circuited one. So we need to find out the length from the short circuit termination. So this is your short circuit termination, that is the extreme right on a horizontal line. So this is your short circuit termination, and the wavelength at this extreme right point is 0.250 lambda. So we need to find out L from 0.250 lambda to 0.340 lambda. This L, that is the length, is the difference of these 2 points. So we will do the same. From the Smith chart we can find length L equals to 0.340 lambda minus 0.250 lambda. So the difference of these two will be 0.090 lambda. So that will be your length. You can do this, say all these things with the analytical methods also. I have given this solution in the slide. So if you want, you can copy this solution, and from this also we are getting the length equals to 0.0903 lambda with the analytical solution also. Okay, so in this way we have solved, or we have designed the impedance matching circuit by using single stub. So the final solution for this will be, this is your stub, this is your load, and this is a shunt short circuited stub. Then the distance from the load to the stub is 0.219 lambda, and the related length of a stub is 0.0903 lambda. So this is your solution for this sum. So you can try it on a Smith chart. Thank you.